Before coming to our main topic, first we need to understand about the principle of lightning. Lightning is an electric current. To make this electric current, first you need a cloud. When the ground is hot, it heats the air above it. This warm air rises. As the air rises, water vapor cools and forms a cloud. When air continues to rise, the cloud gets bigger and bigger. In the tops of the clouds, temperature is below freezing and the water vapor turns into ice. Now, the cloud becomes a thunder cloud. Lots of small bits of ice bump into each other as they move around. All these collisions cause a buildup of electrical charge. Eventually, the whole cloud fills up with electrical charges. Lighter positively charged particles form at the top of the cloud. Heavier negatively charged particles sink to the bottom of the cloud. When the positive and negative charges grow large enough, a giant spark, lightning, occurs between the two charges within the cloud. This is like a static electricity sparks you see, but much bigger. Most lightning happens inside a cloud, but sometimes it happens between the cloud and the ground. A buildup of positive charge builds up on the ground beneath the cloud, attracted to the negative charge in the bottom of the cloud. The ground's positive charge concentrates around anything that sticks up, trees, lightning conductors, even people. The positive charge from the ground connects with the negative charge from the clouds and a spark of lightning strikes. Now coming to our main topic. Could lightning ever be harnessed as a usable power source in the future? Does a bolt of lightning provide enough energy to power a town? There is a way to get a fair estimate. Let's find out how many volts are in a lightning strike. From articles in Wind Power Engineering and Development. After some calculations, we get the power of an average lightning bolt equal to 10 billion watts. Now assume this energy is released in 1 second. So the power is 10 billion watt seconds. On your electric bill, you'll see you pay for watt hours. So let's convert watt seconds to watt hour. So let's divide this with 3600 seconds. We will get 2.7 megawatt hour per our average lightning bolt. But can that power a town? And if so, for how long? How much power does a single house consume? Again we have to play with averages. By taking world average, one house needs 1200 watts per hour to keep the fridge, furnace, computer, and all things plugged in going. In one day, 24 hours, the house consumes 28,000 watt hours, which is 0.028 megawatt hours. So if we divide the power draw for the house into the power of a lightning bolt, we'll have the number of houses that bolt can power equals 96 houses per bolt of lightning for one day. So the answer to the original question is that a big bolt could power a small, 96 house town for a day. That assumes we can catch all of that average bolt of lightning in a large capacitor. But it's not at all an easy task. To start with, attracting a lightning bolt would take much more sophisticated equipment than an iron key at the end of a silk string. Tall metallic rods extending high above the ground would do the trick, drawing any electrical charges in the atmosphere and directing them into a facility. But robust and dependable safety mechanisms would also need to be built to immediately contain the huge burst of energy and prevent the entire facility from being blown to bits. And even during a thunderstorm it's incredibly difficult to predict when and where lightning will strike. Assuming that you are lucky and get a lightning bolt to hit your conductor, there would be major difficulties in storing the energy and then converting it to alternating current so it can run your appliances. In addition, any solution to these problems would need to be able to withstand the enormous surges in energy generated by each strike. Finally, much of the lightning bolt's energy goes into heating the surrounding air to temperatures greater than the surface of the sun. So even if you manage to overcome the problems of collecting, storing, and converting the energy from the lightning to make it useful, you would still only be harnessing a small proportion of the lightning bolt's power.